Today I want to talk about data models all the way. And 4 years ago I was giving a talk, and in the talk I had this screenshot from Twitter, and I showed that it had an inconsistency in the UI, because it's like displaying different data about my profile in different places at the screen. And now the good news is that bug is still present today. So that means that I can still use that same example. Now, of course, this would be all awkward if there were engineers from Twitter in the room. Sorry, Paul. But anyway, let me just quickly show you it. I mean, it's not that this is particularly interesting. It's just a nice example of a problem we often have. So what happens is, like, if you change your profile and you save it, and I hope that nobody fixed it today, then you see that the view is kind of inconsistent. So over here I have the old display name, but over here it changed. And so that problem isn't new. Basically, in 1793, there was a similar problem being solved. And the way the world looked before that year is that it was very hard to communicate what the measure of a thing was. Why? Measurements were basically based on the length of a barley corn. Now you might be wondering, how long is a barley corn? Well, there's a rule of thumb for it, and that is like 3 barley corns, they make up 1 inch. Now, how long is an inch? Well, I said that's basically where we get the notion of a rule of thumb for, because an inch, that's roughly the length of the top part of your thumb. So that's where the expression comes from. Now, you can't measure all the things in the world with just your thumbs. That's annoying. So we also have food. And how long is a foot? Well, that's 11.65 inches. That's not an entirely convenient conversion rate, but anyway. But actually, it depends how long a foot is, because it could also be 13.2 inches. I mean, it just depended on where you're living, or maybe how big your feet were, I don't know. And so, beyond inches and foot and barley corns, we had also poppy seeds and lines and digits and fingers and rods and chains and furlongs and miles and nautical miles. All those concepts we were using just to express how long a thing is. And so, there's a conversion table you could draw from that, like how all those things relate together. And it's pretty complicated. And this is just only about measuring distance or length. So if you go add to that mass or volume, then you have just as many concepts you need to know about. And so what happened in 1793, they invented the metric system. And so the metric system, it introduced the mètre. It was invented here in France. And so a meter, it was defined as being 1/10 of the millionth from the equator to the North Pole. That is super arbitrary, but it works really well, because we could also introduce the centimeter, which is 1/100th of that. That's what centi means. And there was a kilometer, which was 1,000 meters. And it's like, suddenly we didn't have any conversion tables anymore. And actually, suddenly it makes total sense that, like, going around the world over the equator, you could call that 40 megameter. And maybe you never heard of a megameter, but you still know what it means. And so, how did we get to this metric system? Well, we have one guy to thank for that, and that is Napoleon. I mean, you might know him from conquering countries and then losing them again. I mean, but that's not like the impressive thing he left in the world. The impressive thing he left in the world is that we're now using the metric system. So you could say, and please prepare for the worst pun in the history, he is the most important ruler ever. So anyway, how the metric system works, it gives a model of reality. It's not anymore an actual description of reality. It's not reality itself, like a thumb or a foot. Like, those are real things. A matter, it was just an abstract thing. But it gives us a model which is really powerful to work with. It communicates really well. It means that we can innovate really quickly. It means that I can bring my laptop from the Netherlands and plug it in here in France, and I'm pretty sure that the power socket is going to fit. That's because we all standardized on this abstract model. Now, if we go back to this Twitter example I started with, basically, when we think about it from a component perspective, there's kind of two independent things. There's a component that's probably showing my profile or something and fetching the data for that from the server. And there's also a different one fetching the messages. And the problem they have is the same problem as we had with food measurements. Like, the two components, they do both what makes sense to them locally, but they have no shared concept of what a user is. Like, they have both their own model. And so in isolation, it makes sense. But if you look at it from a user perspective, it's inconsistent. So it's not really a holistic approach to the problem. So in code-wise, it's nicely decoupled and side effect free because everything stays locally. But actually, as a user, we have a more holistic notion of what a person is, what a user is. And we want to see only one user of me in that system. And so we often can think of state just being data you get and you display and you update. But that's an approach which is a little bit too simple. State is also about identities and relations. And regardless how or what or when something is updated, identity should be preserved. There's only one very specific tweet and one me, and a lot of things we refer to in the natural world, in our natural language, they have a very specific identity. So if we take a more holistic view of the problem of state, you could say that, like, showing a profile is about showing user information. But showing messages is not just about showing tweets, it's also about showing user information. For example, my name. But nonetheless, of course, if we make a request for a tweet, we want to still have this one nice outgoing query that fetches all the data at once. So that means that if there's a response coming back, it also kind of needs to be normalized back in those concepts in which we model our problem domain. So basically what we need is a backend for frontend. And so we have several ways of modeling problem domains. For example, we can use GraphQL, in which we can really neatly model our backend and what's coming from there, the data types we have, but also the mutations and the queries and the things they accept. But something completely else also exists. That's like mobx-state-tree. I talked about it 2 years ago. But basically, it's having a model for your client-side state, describing the data shape, but also describing the local actions that are available on them, the data that can be derived from them. And so there are multiple ways in which one can model a problem domain. And of course, that kind of can get annoying. So you have a GraphQL model, and maybe you also have a TypeScript model of the data, or generated that. And then there's also the mobx-state-tree model. And a lot of people are like, there's now so many models of basically the same thing. It's kind of getting annoying. And so basically, because like a lot of people were struggling about that, I took some weeks and I wrote this library called mobx-state-tree. And the basic concept of it is like this. So you have the server, it exposes the data, and you have the client where you want to have unified concepts of the model. Now, if you then take the GraphQL description, you could simply generate mobx-state-tree models from them. So you have the same model on the server as you have a MobxStatetree. But since MobxStatetree models are very extensible, it means that you can extend them with local state, for example, state that only lives on the server, and for actions and views, in the way it's already done in MobxStatetree. And then when you make a request or a mutation or a query, because it's all scaffolded, you can do that in a very strongly typed way. And then when the data comes back, it's normalized, it's parsed, the right kind of models are instantiated. If I receive new data for a user I already know about, it's nicely merged into that object so that the result is a consistent UI. So let's go for a little demo what it looks like in practice. So please shout if this is too small. It's okay? Cool. So this is the GraphQL schema of a very simple Twitter clone. So it has users, messages, and queries, and a bunch of mutations. And now I also here have a models directory, which is currently empty. But what I can do is I can basically scaffold the model into that. So it parses the schema definition, and it generates a bunch of files. So what it does, it generates a model definition for every GraphQL type I have, but this time expressed in MobxStatetree models. And it also gives me an entry point where I can start adding my own actions and my own local client-side state on top of that. And beyond that, it also generates a store for me where all those normalized concepts are stored. Now, I have the small Twitter demo running here, but it isn't showing any information yet. It's not showing any tweets, it's just loading. So let's go back and show what it means to use those MobxStatetree models for that. So what I start with is by importing the use query hook from my generated code. And then I make this an observer component so that it hooks into the reactivity of mobx. And I can basically call a query, so it gives me the store, and the nice thing about it is that it's strongly typed. So it grabs the store from the context, and basically now I have methods for all mutations and all the queries that do exist in my model. So I'm going to query for the messages, and for that I need an offset, for example, and I need a count. How do I know? Well, it's type checked, because the present information was present in the GraphQL definition, so we can autocomplete on that. So, and then we can't just send a query, we also have to specify what we want to get back from that query. Now, I could write a GraphQL tag query or just a plain string in there, but those that are a little bit familiar with my work know that I kind of hate programming in strings. So it also scaffolds a query builder for me. So because it's strongly typed, it does know that this query is about messages. So it gives me a function which gives me a starting point of a query. And then I just have a fluent interface in which I can simply autocomplete, and it gives me all the fields that are available for that query. So I want a text, I want a timestamp, and then also I want to go into the user object. And I can repeat the same trick. So it knows that like the user has a name, it also has an avatar. So I can select those. And so now I can just check for loading, type a little bit quicker for the error. There we go. And so let's now map over the data we get. And again, so this is nicely strongly typed. So it does know what the query is going to return to me. And so remember, this is not just plain data. These are mobx-state-tree models. So if they would have actions, I could be calling them directly. So let's finish this up. And now it did load all my messages. And I did do that based on the query I just wrote. And so what is more important to demonstrate the problem I started with, if I have this unrelated piece of component which is just updating my profile, and I use that to change my name, and it sends a mutation to the backend, and it comes back, then also in messages it's updated. But not because the query is re-executed. No, it's updated because I got data back, it updates the model, and through the reactivity system that's propagated through the UI. So the query itself is not invalidated, it's just the data models they have, they are updated based on my response. Now, I have a second demo, just to take this a little bit further. So this is the very same application. I just styled it a little bit better. And so here we have the concept of a like. But it isn't implemented yet. So it isn't part of the schema. So what we can do from here on is that we introduce the concept of a schema, of a like. We also write a mutation that describes which message and which user is liking that message. We save it, and then we can just scaffold the client code again. And so what you'll see is that now it extended my model, and it knows about this new property. And the same in the store, we know now about this new mutation. Now, interestingly enough, I already implemented this on server, like not to make this demo too long, but actually for the server, I'm generating the very same models, because like the data structure is the same, so why shouldn't I be using the same on the server? Anyway, so now we have updated model definitions. So now I want to extend the local model I have for messages based on what we saw so far. So to display a like, so basically to highlight this heart, I have to know whether I liked it. Now I could compute it on the server, like based on my session ID or something, but actually this time I decided not to, so that like the server can respond to the questions unaware of who I am. And rather this time I'm going to solve it like client-side. And so I'm going to introduce a view on this object. And it's basically a computer property saying like, is this tweet being liked by me? Now when is that the case? That's the case when if I look into the collections and it includes me. And now me is the user object that was already fetched for my profile. And so the interesting thing is like, because this is a computer property, it means that if either the likes collection changes or the current user changes or whatever, that is immediately properly reflected in the UI. And also I want to have an action that like invokes the source mutation. And so I need to have the right mutation, so mutate like. And I pass in the params. So yeah, that should be an ID of myself. And again, I'm going to use that query builder to make sure that I strongly type check on what I want to get back from the server, which is the updated collection of likes. So make sure I close all the parentheses. Yep, so that fixes that. And so if I now go, oh, of course I should update the component as well. So here's the component. displaying message. It's not doing anything yet, but it's having this heart icon, which currently has a like class. And so let's make that conditional based on the fact whether I liked it or not. So if I liked it, it gets 2 classes, otherwise 1. This is very not CSS and GS, but anyway, this is what I know. And so if I go into the message, then I have now not just the state I got from the server, but also the actions I introduced, like this like method available. So I assign the like method to the onClick handler, and then I'm basically done. So I should now be able to like my own or everyone else's messages. So I clicked it, and oh, okay, something happened, but it was kind of slow. Why is it so slow? Well, I hard-coded a 2-second delay into the server, just for fun. So actually what we want to do here is an optimistic update. So let's get to that. And so when you have a mutation, you can always give a third function which performs an optimistic update. And so the update, that's just programming directly against the model I have. So I'm just going to check, is it liked by me? Then I'm going to remove myself from the likes list. And otherwise, I'm going to add myself. So there we go. This is now optimistic update, which is directly applied onto the model we have in memory. So we save that. And now if I click the like button, it immediately responds. Now the question, oh, actually it doesn't really respond. Oh no, it does, okay. Maybe if something was really reloading or something. Anyway, so it's now optimistically updated. The problem with optimistic updates, of course, is that they can go wrong. So let's check what happens if we just plainly kill our server. So no server running anymore. And now I click it again. And you see a very quick flash, but it immediately reverts to chains. So, and to revert the chains, that's possible because MobxStatetree has first-class support of recording patches and inverse applying them. I mean, you might be tempted to do it with snapshots or time traveling, but that would fail as soon as you try to do something else concurrently. But when you have JSON patches available, you can reverse apply the effect of the user and get that effect. So basically, how that is implemented behind the scenes is it starts a patch recorder which keeps track of all the low-level changes that are happening caused by the optimistic update, which is called over here. Oh, that doesn't work that way. And then if the query fails, I simply undo it. And that's in generally a quite reliable way to undo most of the optimistic update changes. And so there's one last thing I want you to notice. So if you look at this message component, no, actually this one. So if you look carefully, this is a TypeScript file, but there's no single type annotation anywhere in this code. Yet, even though that's not there, everything is still strongly typed. So yes, you can get really far without ever needing a type annotation. And so it means that like the compiler is just able to verify whether your queries and selectors, whether they are correct. So that is basically what MobxStatetree GraphQL is about. It's like the idea of taking one model and propagating that through your stack. And it's especially really convenient if you have to use this model in multiple places in your UI, the same concept in multiple places, and you want to have that consistent, you want that to have local extensions, or maybe just because you want to test that stuff standalone. Now, what I like about this the most is, I mean, like, regardless of whether you're ever going to use this or not, what I like about it the most is the conceptual journey we can make. And that we can do that with this tool or probably with other tools as well in the future. But so we have a concept that is true for our business domain, like measurements were for people back then. And so we start with our GraphQL model definition. And from that, we generate mobx-state-tree models so that you don't have to write them. And since mobx-state-tree has first-class support for TypeScript, it means that all your type checking is also in place immediately. But this stack is even longer than that, because probably you're not even writing your GraphQL schemas entirely yourself. Maybe you're using tools like AppSync or Hasura to generate the schemas from your Postgres database. So what it means is that like, if you change the database schema of your database, this single concept of a model can propagate through your stack and make sure that you get the right autocompletion in your favorite IDE. And you can actually take it one step further. Because it's all generated code, it means that you can also repeat this very same process in your continuous deployment environment. So what you could do is, in continuous deployment environment, you just, again, run the scaffolder to generate your model classes. But this time, you run it against your production endpoint, for example. And then it means that the compiler is able to verify that everything is still ready and valid and compatible and ready for production. So that's what I wanted to share about mobx-state-tree for GraphQL. It's basically a backend for frontend. Can I use it? That's, of course, the most important question. The answer is no, because it's not yet public. But that's something we can change right away. Oh, that's not the number. Oh, cancel. Okay. So now it's public. Doesn't mean that you should use it. I don't know entirely about it yet. I mean, I started on this like 2 weeks ago, and so it definitely isn't stabilized or matured yet. So for that, I need you, because I'm not working on any actual GraphQL project. And by the way, I'm already maintaining enough stuff. So if this makes sense to you and you could benefit from that, please join into the repository. And if you do that, please contribute. I would be thankful for that. A lot of people would be, because I get a lot of questions specifically for this. And so with that, merci beaucoup.